Every single minute, 300,000 used diapers enter landfills and incinerators around the world. They sit there for 500 years, untouched. Now imagine a massive industrial refinery built for one purpose and one purpose only: to shred, sterilize, and melt these mountains of waste down into molecular building blocks. Billions of soiled diapers enter this machine and emerge not as trash, but as pristine, snow-white plastic pellets destined to become furniture, roof tiles, and construction materials. This is the dirty, high-tech secret the diaper industry doesn't want you to see. Every baby's diaper masks an environmental disaster. 27 billion diapers a year in the US alone become 3.5 million tons of landfill waste that lasts 5 centuries. Now, innovators are building refineries to convert that filth into clean plastic pellets. But past attempts have crumbled under cost and stench. Can they finally succeed? We're about to see. A disposable diaper is an engineering marvel of mixed materials. A soft inner layer of polypropylene that touches the skin. A fluffy core of cellulose pulp to absorb urine. And hidden within, the secret weapon, a superabsorbent polymer, a sodium polyacrylate that can lock away 200 times its own weight in liquid. Plastic backsheets, elastic and adhesives bind it together. Land works perfectly for a few hours on a baby, then becomes a permanent problem. Because nothing separates easily once it's fused and soaked. Across a child's lifetime, they'll go through 5,500 diapers. Multiply that by the global population of infants and toddlers, and you get roughly 250 billion diapers discarded every single year. Landfills swell with them. They compress into impermeable, mummified packages that refuse to rot. The plastic remains after half a millennium. The cellulose pulp, which could break down in weeks, is entombed in layers of polypropylene and the gel-like polymer, starved of oxygen and microbes. Incineration burns some, but releases carbon dioxide and toxic residues while wasting materials that cost energy to produce. The scale is so staggering that nearly 4% of all municipal solid waste is just diapers. For a product used once and thrown away. The idea of recycling diapers isn't new. In the early 2000s, a pioneering company called No Waste saw the opportunity. They built processing plants in the UK, the Netherlands, and later Canada and California. Their technology was impressive. Shredding, screening, and dry sterilizing the mess to recover cellulose fibers and plastic. The cellulose became tissue paper. The plastics were pelletized into roof tiles. But the economics broke them. Running these plants required immense energy, enormous amounts of water and chemicals to deal with fecal matter, and a constant battle against odor drifting into neighboring communities. One planned London plant was scrapped in 2017 after intense local opposition over exactly that. The smell of millions of dirty diapers arriving on trucks every week. No Waste's operations quietly shuttered one by one, leaving behind a trail of bankrupt hope and a stubborn question hanging in the air. Is diaper recycling physically possible but financially fatal? That question haunted industry for years, until a quiet corner of northern Italy became ground zero for a fresh attempt so audacious it promised to turn 100% of a used diaper into something saleable. No landfill, no incineration. A complete closed loop. And the entity behind it wasn't a scrappy startup. It was a joint venture between consumer giant Procter & Gamble and the Italian conglomerate Gruppo Angelini. They built a plant capable of swallowing 10,000 tons of used absorbent hygiene products per year, items collected from municipal waste streams and special bins. They called it the Lavadina facility, and for the first time on an industrial scale, it claims to work. But to truly prove it can beat the ghosts of past failures, the process inside has to be so extreme that it borders on alchemy. And the price tag to keep it running? That's the brutal cliff we now climb. Inside the Lavadina plant, the first thing you notice is the smell. Even through layers of sealed doors and negative pressure airlocks, the ghost of ammonia and anaerobic decay hangs thick. Convoys of trucks arrive daily from municipal collection points across northern Italy, each loaded with bales of used absorbent hygiene products. Not just baby diapers, but adult incontinence pads and feminine hygiene items. 10,000 tons per year enter this facility. The bales are ripped open, and the unsorted, soiled mass is fed onto conveyor belts. No one touches it. The entire receiving bay is robotic, enclosed, and constantly scrubbed. The waste looks nothing like recyclable material. It is dark, wet, and biologically active. The first machine they enter is a shredder capable of tearing through bone, metal snaps, and plastic film. The material is reduced to palm-sized fragments. These fragments then travel into the heart of the plant, a horizontal autoclave. It is a steel cylinder over 20 meters long, rated to hold 40 bar of pressure. Inside, the shredded diapers meet superheated steam at 250 degrees Celsius. The pressure and temperature are equivalent to those found 1,000 meters deep in the ocean next to a volcanic vent. Nothing living survives. In minutes, the cellulose, plastic, and superabsorbent polymer are cooked into a molten porridge. The polymer gel, which had locked away urine and feces, releases its grip. The polypropylene backsheet and polyethylene films melt into glowing amber globules. Cellulose fibers separate and float free in the hot slurry. This slurry is then blasted through a series of dynamic screens and hydrocyclones. The cellulose fiber, now sanitized and loose, gets filtered out, washed and dried. It emerges as clean, bright pulp, identical in quality to virgin fiber, ready to become tissue paper, cardboard, or insulation. The plastic globules, a blend of about 70% polypropylene and 30% polyethylene, are skimmed from the top, cooled, and run through an extruder. The extruder dies cut the molten plastic into tiny cylindrical pellets, which rain into holding silos. They are odorless, sterile, and light gray. Pellets that will soon be loaded onto trains and sold to manufacturers of garden furniture, drain pipes, storage bins, and construction profiles, anything not destined for skin contact. It sounds like alchemy, and in many ways it is. The Fader technology recovers up to 85 to 90% of the raw materials entering the plant. By 2019, the joint venture was declaring the process viable at industrial scale. Virginie Helias, P&G's Vice President of Global Sustainability, called it a technology that can turn 100% of diapers into valuable material. The EU, which has mandated increasingly strict landfill diversion targets, celebrated the milestone. Yet, running this machine costs a fortune. The energy needed to maintain 250 degrees and 40 bars across thousands of cycles is enormous. The water and chemical treatment systems required to handle the pathogen-rich effluent add another layer of expense. Early estimates suggest it requires over 86 watts of electricity per kilogram of diaper waste processed. That is not trivial when scaled to millions of kilograms. And then there is the ghost of no waste. Their plants prove that recycling dirty diapers into clean pellets was technically possible decades ago. But they died because the cost of the pellets could not compete with cheap virgin plastic, and municipalities refused to pay the gate fees necessary to keep the doors open. Residents near the proposed London plant successfully blocked it over odor fears. The Fader facility in Lavadina runs on a public-private partnership with local waste management entities that subsidize those fees, but it is an island of success. Scaling it across Europe, let alone to North America or Asia, would require a massive shift in how societies pay for waste. The price tag to keep this running is a brutal cliff indeed. But here is the thing, P&G isn't doing this just for green credentials. Something else is pushing the industry toward a future where every used diaper becomes a resource. A threat that, if ignored, could make the entire disposable diaper business model illegal or financially untenable within a generation. And its roots are buried not in a high-tech Italian autoclave, but in a public toilet in Japan, where a very different experiment revealed how consumers might finally be forced to confront what they flush away. That is where our story takes an even stranger turn. In 2015, Japan's largest hygiene products manufacturer, Unicharm, launched a pilot project so quietly radical that most of the world missed it. The town of Shibushi, on the southern island of Kyushu, became the first municipality in Japan to collect used adult incontinence pads separately from regular trash. Residents dropped their soiled products into dedicated bins at community centers and care facilities. The material was collected, transported under biohazard protocol, and fed into a machine that looked nothing like Italy's massive autoclave. It was smaller, modular, and used ozone gas instead of steam to sterilize. The system shredded, washed, and separated the waste into 3 streams: plastic film, superabsorbent polymer, and cellulose fiber. And here is the twist: that cellulose fiber didn't become industrial cardboard. It was pulped, bleached, and rolled into something every human consumer understands intimately: toilet paper. And the public was told exactly what it was made from. In a 2-month trial, 98 metric tons of used hygiene products were collected. The facility produced 30,000 rolls of toilet paper. Unicharm branded it as part of their REF project, short for refuse to fiber. Unlike the Italian plant that sells anonymous gray pellets into the construction supply chain, this Japanese experiment closed the loop in full public view. Consumers used the product, disposed of it, and bought it back as tissue. The psychological barrier was immense. Imagine wiping with paper that, not long ago, was a stranger's incontinence pad. But the town of Shibushi leaned in, and the trial ran without a single major contamination incident. The recycled pulp, tested independently, matched the whiteness, strength, and hygiene of virgin pulp. Ozone sterilization destroyed every pathogen, including heat-resistant spores that steam sometimes misses. The process was clean, the product indistinguishable. Technically, it worked brilliantly. But Japan wasn't running this trial out of curiosity. The country's demographic crisis is rewriting the waste map. Japan sells more adult diapers than baby diapers now, a trend accelerating across every aging industrialized nation. By 2025, people over 65 will outnumber children under 5 globally for the first time in human history. The diaper waste crisis isn't a baby problem. It's an aging society problem. Adult incontinence products are larger, more heavily soiled, and landfilled at even higher rates. In care homes across Europe, North America, and East Asia, the volume of these products is projected to triple by mid-century. Governments are staring at a tsunami of absorbent waste with nowhere left to bury it. The economics of "just throw it away" are collapsing in real time. Enter the Ellen MacArthur Foundation. In 2019, the Global Circular Economy Authority published a scathing report that named absorbent hygiene products as one of the most wasteful, least recoverable consumer goods on the planet. Nearly 40 million tons of waste is created every year by nappies globally. The foundation signaled that regulations were coming: mandatory collection, extended producer responsibility laws that force manufacturers to pay for end-of-life processing, and outright bans on landfilling untreated hygiene products. The EU had already floated legislation requiring member states to divert 90% of absorbent product waste from landfill by 2030. Non-compliance would carry fines large enough to gut corporate balance sheets. Suddenly, the question wasn't could dirty diapers be recycled, but rather, which companies will still be allowed to sell them if they can't be. This is the real engine behind Lovedina and Shibushi. Procter & Gamble, Unicharm, Kimberly-Clark, and Essity are not just pursuing green credentials. They are racing to patent and lock down the recycling technologies that will become mandatory to operate in the markets they depend on. The company that controls the dominant recycling method controls the industry's future. Fatter's P&G-backed autoclave technology has been patented across Europe and North America. Unicharm's ozone-based sterilization process is protected across Asia. These are not public good altruism projects. They are strategic weapons in a quiet war for regulatory survival. The losing companies will face a future where their products are banned, taxed, or smothered under compliance costs. Billions of dollars in annual revenue hang on which technology scales first. But nobody has yet solved the fundamental problem that killed Noesti. The cost of running these plants still exceeds the value of the materials they recover. The cellulose sells for a fraction of virgin pulp. The plastic pellets are contaminated enough that they trade at a discount. The super-absorbent polymer, the most expensive component, is largely destroyed in the recycling process and lost. Without heavy subsidies, the economics invert, And that's where the story arrives at a terrifying question. What if a government decided to make diaper recycling mandatory before the technology was ready? What if a city was forced to build a plant, and the plant failed? Because it already happened, and the consequences were worse than anyone imagined. The city was Kingston upon Hull in the north of England. The year was 2016. The local council, faced with punishing landfill taxes and an EU mandate to divert 65% of municipal waste, made a desperate bet. They signed a contract with an Anglo-Dutch recycling consortium to build a dedicated diaper processing line inside the existing waste treatment center at Saltend. The promise was attractive. Divert 30,000 tons of absorbent hygiene product waste annually, produce clean fiber and plastic pellets, and cut carbon emissions by nearly 1,000 kilos of carbon dioxide per ton compared to incineration. Construction started fast. The machinery was imported, the shredders installed, the sterilization chambers welded together. But the fundamental flaw was baked in from the start. The technology had never been run at scale on the specific waste profile of Hull, a wet, cold city, where diapers arrived mixed with garden waste, food scraps, and industrial rags. The upstream sorting infrastructure didn't exist. Within 3 months of commissioning, the plant was overwhelmed. The pre-shredders jammed on textiles and plastic wrappers that the separation system couldn't handle. The autoclave, undersized for the contaminated load, failed to reach uniform sterilization temperature across the drum. Pathogen tests came back positive 3 times in the first 10 days. The odor control system, designed for a milder input, buckled. Residents within 2 kilometers reported a stench so severe they couldn't open their windows in summer. Emergency council meetings were called. The operator, bleeding cash, demanded renegotiation. The council refused. The plant was mothballed in 2018, after just 19 months of operation. The total loss exceeded £14 million of public money, and the diapers that had been diverted sat in sealed containers for 2 more years before being trucked to an incinerator anyway. The attempt to force diaper recycling before the system was ready didn't just fail technically. It poisoned public trust. Other UK councils that had been watching Hull quietly shelved their own plans. For almost 5 years, the phrase diaper recycling became political kryptonite in British local government. And yet, that very disaster produced the data that saved the next generation of plants. Fodder's engineers obtained the operational logs from Hull under a confidential agreement. They studied every failure point, the jamming sequence, the temperature gradients, the perimeter air sampling reports. The Lavadina plant that opened a year later incorporated 27 specific design changes traced directly to the Hull breakdown. The lesson was cold but clear. Successful diaper recycling requires total control over the input stream. It cannot work as a casual drop-off for mixed municipal waste. It demands segregated collection, intensive public education, and a ruthless pre-sort system that rejects anything not recognizable by the optical scanners. The Italian plant works because it is fed by a dedicated logistic chain that starts with specially labeled bins at nurseries and care homes, and ends with bales that are audited for contamination before they ever reach the shredder. The cost of that infrastructure is immense, and it is now clear that at current market prices, no fully private operation can afford it without sustained government subsidy or mandatory extended producer responsibility fees that force the diaper makers themselves to foot the bill. That brings us to the final, surprising turn in this story. While the Western approach battles economics and politics, a quiet breakthrough in material science may have flipped the entire equation. Researchers in Finland, working with the recovered superabsorbent polymer that most plants discard as worthless, have demonstrated a process to relink its molecular chains after degradation. The result is a recycled superabsorbent that retains 80% of the original absorption capacity and can be sold into agriculture as a soil moisture agent for arid farmland. Suddenly, the most expensive and elusive component of the diaper becomes a revenue stream, not a waste product. If that single innovation reaches commercial scale, the economics of every refinery, from Lavadina to any future plant in Asia or the Americas, shift from survival mode to genuine profitability. The pellet output could become a byproduct, not the main prize. The industry's hidden war might just have found its unexpected weapon. And it was grown not in a boardroom, but in a university laboratory that nobody was watching. That lab in Finland didn't set out to save the diaper industry. They were trying to solve water retention for drought-stricken farms. But their molecular breakthrough cracked open a future where every single dirty diaper could become a net profitable resource, not a disposal crisis. And that's the larger truth of this story. The world makes 250 billion disposable hygiene products every year. For decades, we treated them as the ultimate linear consumption, use once, bury forever. Now, driven by regulation, demographic pressure, and the quiet stubbornness of engineers who refuse to accept that a problem this big can't be solved, that line is bending into a circle. It is messy, expensive, and politically fragile. It has already produced spectacular failures and a few cautious successes. But the refineries exist now. They turn filth into saleable pellets while cutting carbon footprints by over 80%. The next time you see a baby or an elderly person wearing a diaper, you are looking at the raw material for a roof tile, a park bench, or maybe one day, a roll of toilet paper that carries an invisible history. If this story hit you, hit subscribe. We go deep into the hidden systems that keep the modern world running and what happens when they break. See you in the next one.